All right, so here's our first little activity that we're going to be doing with the scientific method. So it says, after completing the table, read the passage, which is the experiment. And this is kind of what you guys will be doing on your own, utilizing the information that we have. So if you've gone through the scientific method notes, this part should hopefully be a review for you guys. Okay, so anytime we go through the scientific method, remember, we want to solve a problem. And part of this little scenario is that you guys are going to be going through and kind of figuring out what our problem may be. It should always be supplied to you. That's why you're doing the particular experiment that you are. So once you guys read your little passages, you guys are going to create a hypothesis. Once again, a hypothesis does not have to be correct. It is an educated guess based on the information that you know. Maybe you don't know anything about it. Well, maybe you need to research it a little bit. Ask a friend, read it within a book, look it up online, whatever it may be. But this hypothesis is a possible solution to the problem. It is a prediction. What do you consider is going to happen here? Remember that we have two types of data that we discussed. Quantitative, remember quantity means number, so try to keep that straight in your head. So that's measurement in numbers. It's data with units. And qualitative, quality, which is more descriptive in words, features. Clouds are fluffy, sidewalk is long, the dog barks loudly, things along those natures. It's more descriptive. There are no numbers that are included in qualitative data. You guys are going to be doing repeated trials, and if we don't do repeated trials, we will collect data from other groups. So if we have multiple lab groups doing the same experiment, I might say, great, let's collect data from all of our different groups and average them. By doing the experiment multiple times, we get more valid or believable data. Maybe your group made an error within the experimental setup and your data is way off than everybody else's. Well, if we're averaging them, then we can get a more accurate picture of what the data should look like. So we want to do the experiment a minimum of 3 to 5 times in order to get better data. And like I said, it's not like your group is going to be doing the same experiment over and over and over and over again. We might collect data from other groups that are doing the same experiment. Your independent and dependent variable. Your independent is that x-axis. It's the one that runs along the horizontal line there. It is the one thing that you are testing for in the experiment. This is what you will control. So as we're going through our little experiment here in a moment, you guys will see that. Your dependent variable, which is the y-axis, is going to be the results of the experiment. What happened? Remember that when you guys label your independent and dependent variables, you guys need to make sure that you are including units with it, meaning milliliters, liters. If it's time, you want to do seconds or hours or months or years, whatever it may be, make sure that we're including units with the independent and dependent variables or our x and y axis. We also have words like control and constants. Control is that normal, what normally happens, our non-experimental group. This control is used for comparison. So my first part of the experiment, I'm looking at control, I'm collecting data. Now I'm going to change something within that experimental group, and I'm only changing one thing, and that's that variable. And I'm running that experiment again, and I'm comparing it back to my control group. How did it change when I changed that one variable in it? How is it different than this control or my normal group? Constants, notice that there's the S on the end, means that we have multiple of them. It's everything that stays the same between the variable and the control or the experimental groups. So once again, if we were looking at plants, same type of plant, same size pot, same type soil, same location in the sun, everything should be the same about them, except for the one thing that we're testing for. So maybe we give them different amounts of water. That's the only thing that should be different from them. So thinking about that, we want to look at this little experiment. So it says a shopping mall wanted to determine whether the more expensive tough stuff floor wax was better than the cheaper steel seal floor wax. So they're going to go wax the floors, and they want to know, we have two different types. Do we want to spend more money and use the Tough Stuff floor wax, or do we want to be cheap about it and save a little money and use the Steel Seal floor wax? Is there going to be that much difference between them at protecting those floor tiles against scratches? 1 liter, so if you think like a liter bottle of water or a liter bottle of soda, 1 liter of each type of floor wax was applied to at least 5 test sections in the main hall of the mall. The test sections were all the same size, were covered with the same kind of tiles. So they were the same size, same type of tiles. The 5 other test sections received no wax. So we're actually doing kind of 3 setups. We're doing 5 test sections with Tough Stuff floor wax. We're doing 5 sections with the cheaper Steel Seal floor wax. And then we're going to do 5 sections that have no wax on them whatsoever. We let that go for 3 weeks. We let the people walk over them. So after a 3-week test period, the number of scratches in each of the test sections were counted. So now we want to utilize that information for what you guys will be seeing on that next page. So I'm going to kind of switch pages here, and we're going to kind of go with what you guys have here. So this is the sheet that you guys are going to be filling out, but I kind of want to start out with you just a little bit with it. So we kind of want to start out with a problem. So if we're thinking about that particular problem, and the problem is, what are we looking at and why are we doing this? Here's my problem. My problem is, what am I trying to solve here? I'm using floor wax, but what am I trying to solve? We're trying to solve which wax works better. That Tough Stuff or Steel Seal. So I'm going to kind of list them there for you. So my 2 that I have Tough Stuff, which is more expensive, and I also have Steel Seal, which is the cheaper version. So just like anything, maybe we've seen commercials on it, like, oh, Tough Stuff, this stuff is great, and you think, oh, well, if you spend more money on something, maybe it works better. Maybe you're like, oh, I've used store brands of most things, and they work just as well as the more expensive brands, so I think that the Steel Seal is going to work. You need to come up with a hypothesis. And basically when we do this hypothesis, and go right across the whole thing, you're going to tell me which brand, the Tough Stuff or the Steel Seal. You are creating your own based on the information that you know. It's not given to you. Which one, Tough Stuff or Steel Seal, will work better? And why? You have to make it a because statement. It will work better. So Tough Stuff will work better because Steel Seal will work better because, what do you know? It's cheaper, it costs more money, the name sounds better, whatever it may be. Come up with your own hypothesis. We are collecting types of data, and when we're collecting those types of data, what we want to look for are 2 different types. So you guys are going to be collecting within that little scenario that you read. Tell me about the types of quantitative. Tell me about the types of quantitative data. What types of quantitative data were collected within that experiment? Also within that experiment, how about qualitative data? What types of qualitative data do you think that we could collect? Remember, quantitative is dealing with numbers of something. Qualitative, more descriptive on that. Okay, so think about that. As you're going through, we want to look at numbers of trials. How many numbers of trials did we have? And then think about it. Remember, we are testing 3 different types. So we should have done the same type for all of these. We have tough stuff. We had steel seal. And you're going, well, you just said we have 3 different ones. Well, we only have 2 types of wax that we're using. Yes, but if you remember the little scenario, it said that they're also going to use one section, or they're going to do one test section of no wax, or the same amount with no wax that they did with these 2. Think about your independent and dependent variables. So what are my independent and dependent variables? My independent variable, remember, is going to be my x-axis. It's what I am testing. So what is that I have there? What am I testing? You won't have anything in this column for reasoning. For your y-axis is your dependent variable. These are my results. What am I going to put along that y-axis? So there's my y-axis, there's my x-axis. What are my results going along, excuse me, that? So you're going to tell me what should go here, and then we should know that these are now my results of the experiment. My control. My control is my normal. My normal is what I use for comparison. What was my control in this experiment? What am I using as my control? So look back at your trials that you did. We use tough stuff, we use steel seal, and we use some that have no wax on them. What's my control? The last little bit, what are my constants? What is staying the same? So remember that these constants are what remains the same. There should be many of them. So when you think about that experimental setup, what stayed the same all the way through? Okay, so I need you guys to create for me a hypothesis. What brand? Steel seal, because why? Tough stuff, because why? Go back, reread that scenario. Tell me what type of quantitative or number data am I collecting? How can I collect some sort of qualitative or descriptive data? How many trials were created? Remember we said the more trials, the better, the more valid that information is going to be. As I'm running the experiment, what will go along my x-axis? What am I testing for? Along my y-axis, my vertical line here, my results of the experiment. What are they? So I should have a little line here. Filling this in, filling this in, I'm filling this in. What is my control, which is used for my comparison? And then tell me my constants. I should have multiple constants there. So go back, reread that little scenario, and you guys should be filling this in. Questions, you'll let myself or Miss O'Keefe know, and we'll go through it with you guys when we see you in class or when we get together on Google Meets together. Okay, so go through, fill in what you can, and we'll go from there.